At the center of this galaxy, a supermassive black hole sits silent and sleeping. Our own Milky Way holds 1,2 Sagittarius A star, 4 million solar masses, barely awake. And such sleeping giants can grow far larger, ranging from millions to 66 billion solar masses. Yet, for now, Skr A star barely feeds, consuming about 1 Earth mass per year. But this wasn't always the case. The Fermi bubbles prove our black hole was active just a few million years ago. To understand that activity, we go back these black holes formed in the early universe through direct collapse and merger. Since then, every large galaxy and its central black hole have grown together, their fates intertwined. Normally, gas in the galaxy stays in stable circular orbits, unable to reach the black hole at all. So 3 things must strip that gas of its angular momentum and send it spiraling in. The most violent trigger is a galactic merger. It disrupts everything, pouring gas toward both central black holes. And when that happens, vast quantities of gas suddenly fall inward, accelerating toward the waiting giant. That gas does not plunge straight in it, first forms a spinning accretion disk around the black hole. As more gas piles into that disk, friction heats it to 100 million Kelvin at its innermost edge. The disk is now brightening, but its luminosity is only half the strength. The other half is the disk's magnetic field, which winds tighter and tighter until something fires. The jet fires, particles launched at 99.9% the speed of light. Inside that jet, a single particle carries the kinetic energy of a speeding car. Within just 10,000 years, this jet extends across the entire galaxy. Meanwhile, as the merger deepens, still more gas falls inward. Around the disk, dense gas clouds now orbit at 10,000 kilometers per second. And all of this disk, jet, clouds is wrapped in a dusty torus that hides the central engine from most sightlines. At the physical limit of feeding, the disk's luminosity reaches 10 trillion times the sun's. This is a quasar, a galaxy outshone by its own black hole. In fact, a quasar outshines its entire host galaxy by a factor of 100. The disk's surface alone burns at 100,000 Kelvin hotter than the largest known stars. And the jet now stretches 500,000 light years, 5 Milky Ways laid end to end. That jet glows across space because electrons spiraling in magnetic fields radiate powerful synchrotron light. Collectively, a single quasar outputs 10 to the 21st power times the sun's total energy. An X-ray corona at 500 million Kelvin sandwiches the accretion disk. From a million light years away, that quasar blazes past everything else in its galaxy. But light isn't all that escapes a quasar. Wind blows at 1/10 light speed, beginning to reshape the galaxy. That wind suppresses star formation across the entire host galaxy. So the galaxy doesn't just observe the quasar is rewriting its future. The jet even heats the entire galaxy cluster, preventing any gas from cooling into new stars. Thus, one black hole transforms an entire galaxy from blue and alive to red and dead. This is the most energetic sustained phenomenon in the observable universe. The peak era for such quasars came 2 to 3 billion years after the Big Bang. Even from 10 billion light-years away, one of those ancient quasars is still the brightest object in the sky. We only see it because radiation escapes through the torus opening. But quasars are not constant. They flicker as dense gas clumps fall into the inner disk. At peak accretion, the quasar consumes 20 solar masses of material every year. After hundreds of millions of years, though, the fuel runs low and the quasar begins to dim. The accretion rate drops to half the Eddington limit, the disk thins, and the jet weakens. Below 1% of the Eddington limit, the disk transforms entirely. The magnetic field weakens, the jet flickers, and finally goes dark. As luminosity drops, the quasar wind decelerates and the shock front fades away. The quasar has now faded to a low luminosity active nucleus, but its galaxy is changed forever. That galaxy, once blue and star-forming, is now red and quiet, a permanent change. Only the radio lobes outlast the quasar itself, the jet's most enduring signature. Those same lobes appear in miniature as the Fermi bubbles, proving our Milky Way was once active just millions of years ago. 2 billion years ago, our galaxy may well have been a mild active nucleus. And when we merge with Andromeda, our black hole will wake and shine again. So, did you know the Milky Way once had an active nucleus? Comment below. A quasar, all said, converts up to 42% of mass directly to energy, the universe's most efficient engine. That's why supermassive black holes are not just destroyers, they are the architects of the galaxies we live in. This is Sagittarius A star right now sleeping, but not forever. Every large galaxy has such a sleeping giant waiting to be woken. And when a black hole wakes, the universe is never quite the same again. If this moved you, subscribe to Cosmic Depth, and we'll explore every Monday. If this changed how you see the galaxy we live in, hit the like button. Thank you for exploring the most energetic event